If you work in the chemical and petrochemical industry, you know the industry continues to face operational challenges on several fronts. Resource pools are shrinking as seasoned instrumentation engineers and technicians retire. Yet there is a continuous drive for greater efficiency and for greater sampling system uptime. Swagelok now offers a solution that allows remote collection and delivery of sampling system data to a centralized location. The result? More informed decisions and faster action, even in the harshest of environments, such as Class 1, Division 1, ATEX Zone 0 applications. Swagelok's Smart System offers the ability to monitor and manage sampling systems using either conventional or SP76 modular process components. Data from a smart sampling system can be used to help ensure flow to critical process analyzers and alert analyzer technicians to impending problems, helping process plants improve productivity, profitability, and personnel safety. Sound too good to be true? Andy Creek, Senior Principal Electrical Engineer, demonstrates the intelligence behind Swagelok's Smart System.
Before I get started, I'd like to just give you an overview of this panel you see. This panel is representative of a traditional sample system that conditions a sample prior to analysis. On the left-hand side you can see a process stream coming in, and on the right-hand side here is where an analyzer would normally be connected to analyze the sample after it's been conditioned. Now in this system we have traditional Swagelok fluid components. We have valves for selecting streams, we have some pressure regulators for regulating pressure, and then we have some transducers, but also for monitoring inlet pressure and other pressures and temperatures in the system. And as you can see in this system, there are some wires. That's not traditional with the Swagelok system. But when you automate a system, you need to have some connectivity to it to provide power for sensors and to provide communication to acquire the data and make it available to your network. As the stream comes in through this system, it ultimately makes its way up to this bank of valves that we call the Swagelok Stream Selector Valves, or SSVs. Opening one of these valves will allow one of these process streams to ultimately flow through the system and make its way to the analyzer. Now as these valves are opened and closed, the process stream flows through these products here, and these are two new products from Swagelok. They're actually two of the same product. We call them our pressure and temperature transducers, or PTXs. And as their name implies, they measure pressure and temperature. These products are suitable for use with a wide variety of automation equipment, PLCs, or any type of DCS that can monitor a voltage output. These products can be used with those. In addition, they can be used with another new product we have here, the Swagelok Intelligent Control Module, or ICM. I'd like to talk a little bit more about the PTX before we talk about the ICM. These products, as their name implies, measure both pressure and temperature. We have two of them in this system because by using two PTXs with the flow restriction in between, differential pressure can be measured, allowing the ICM to turn that differential pressure into an actual flow measurement. So with an ICM, you can actuate valves with its pneumatic outputs, you can monitor digital inputs with its digital inputs, and you can monitor and power your sensors with its analog ports. There are 4 ports on the bottom of the ICM. Each port has both voltage inputs and a current input that make it versatile for use with a wide variety of sensors. Now the Intelligent Control Module is intelligent. It's able to transform sensor data into information, as I explained. It's also capable of executing user-defined test sequences. Much like a PLC, the ICM has what we call an embedded script processor, or ESP. By downloading a script to the ICM, you can control the sequence of valve actuations, you can monitor sensors so that you can determine if an alarm condition is present and communicate that information across the network interface. All of the data that the Intelligent Control Module collects from a sample system is made available on a network interface. This network interface is intrinsically safe, this being the only electrical connection to the fluid system. Both power and communication are present inside this wire, and this intrinsically safe digital data makes its way through this cable, and the network that is used by the ICM is an open standard CAN open interface. That data makes its way down this cable and ultimately over to our operator control station. The OCS, or operator control station, serves two primary purposes. One, it takes CAN open information from the sample systems and makes it available on Ethernet so that a computer can access it easily, actually from anywhere in the world. Once we're on Ethernet, we actually have worldwide web access to the sample systems. The second role that the operator control station fills is to provide a local indication of the conditions of your sample systems. Now I say sample systems because one operator control station can manage up to 25 Swagelok automated fluid systems. So with one of these in your analyzer shelter, you could have 25 sample systems at that location, all of them being monitored and even controlled from the operator control station. Now I indicated that this data is made available over Ethernet, and as you can see here we have a laptop computer running a piece of software that allows the system to be controlled and monitored remotely. Swagelok provides software services, both to develop software for your end application, so you can sit at your desk and monitor your systems. We also provide services to customize the local display on the operator control station. Now, as an example of remote control, I'll show you here on this application. A little bit difficult to see, but right there is the inlet pressure from the 4 to 20 milliamp pressure transmitter. Here's your two PTXs, where you have pressure on the bottom, you have temperature on the top. Right there's a measurement of flow. Because the ICM is smart enough, it's able to monitor this differential pressure and convert that pressure drop into a measurement of flow rate, volumetric flow rate. Now I can start and stop the flow also by just clicking on a valve. By clicking on that valve, I just shut the flow off, and you'll see that the pressures drop and the flow drops correspondingly. If I want to select a different stream, I select that stream, and the ICM just sent a pneumatic signal to the stream selector valve in the center, opening up flow, allowing it to move through the PTXs, and again we have a flow rate measurement there. As you can see, Swagelok's new automated fluid components allow you to take your traditional manual system and automate it, providing complete remote control and monitoring. Swagelok offers a number of services besides just high quality fluid components. We can integrate an entire panel of components for you. We can provide automation at the shelter or operator control level, and we can also provide turnkey software so that you can monitor and control your systems remotely.